Welcome to the Oracle Mobile Application Framework YouTube channel. In this episode, we're going to look at using a RESTful API Modeling Language document, or RAML, to help consume REST services from within Oracle Enterprise Pack for Eclipse, or OEPE. With the MAF 2.1.2 release and beyond, OEPE users can now easily develop applications that interact with REST APIs. The REST Service Editor provides an iterative process for consuming REST services. The editor allows you to explore, test, and review existing REST services directly from the editor. Once you are happy with the service, you simply click a button to import the service as a REST API. A RAML document is a concise way to define the characteristics of an existing REST service. A document may contain definitions of multiple REST resources and operations on those resources. A well-designed RAML document will contain the definitions of functionally related services. For example, one document may contain HR-based services, while another may contain services that relate to purchasing. In OEPE, you can point to a RAML document and import the document to create REST APIs for all or some of the APIs defined in the document. Once they are imported as APIs, you can then create POJO artifacts and consume those as data controls. So that's a fairly generic view of RAML and what it does. The goal of Oracle Mobile Cloud Service, or MCS, is to easily enable mobile application developers to meet their consumers' needs. Developers are continually looking for new ways to accelerate the development of applications. MCS is a set of cloud-based server-side mobile services that make development quicker and easier to deploy. MCS provides a set of rich, RESTful interfaces for all the operations required by a mobile application. These interfaces abstract the back-end from the mobile developer. As part of the back-end development process, MCS developers can create RAML documents to provide the definition of the REST APIs that they wish to publish. That RAML document is exactly what we will use to create an interface with the underlying REST resources. The steps to import a RAML document are pretty easy. Let's take a look at how that's done. So as you can see, I've already created a MAF application. The application is for Fix It Fast, or FIF. I have an assembly project, an application project, and a view project. So the first thing I need to do is to connect to the Oracle Mobile Cloud Service. In the menu, I'll go to Window, Show View, and then select the Oracle Cloud list of options, and then Oracle Cloud. This creates a window where I can connect or open an account. For convenience, I'll drag it next to the Project Explorer. Next, I'll click Connect to create a connection to the Oracle Cloud. To connect to the Oracle Cloud, I need a mobile cloud service URL, an identity domain, a username and password, and the connection name. When the connection is completed, I can then explore the contents of the mobile cloud service. The list shows all of the services that are available based on the connection I've established. For this exercise, I'll be using the back-end service that a developer built for the Fix It Fast application. There are a number of aspects to the Fix It Fast application, but we're only interested in the incident reports. Since the developer created a RAML document that includes the resources and operations we need, we just need to import that document. I select Import Definition to open the Import Wizard. On the last page of the wizard, I can see and select all or some of the resources and methods defined in the RAML document. Once the import is complete, I can look at the REST API tab to see all of the resources that were imported. you can see the import included get and post for incidents, as well as get for returning an incident by ID. It also includes a get and put for status. The import from the RAML document included several query parameters for the get that are not needed. I'll remove both the GPS parameter and the contact parameter. Once those parameters are removed, we can test the get incident API. The copy to REST client icon copies the API so that you can test it. I click send request and see that the request returns a status of 200 OK. And if I look at the raw content, I see that there's data. I can also click the rendered content to see the REST JSON payload of incidents. I can drill down into the rendered content and see that the service returned a number of incidents, like 111, heater water broken, and 112, refrigerator broken. So that's all there is to importing a RAML document to create and test REST APIs. Now that we have the APIs defined, we can create the artifacts that interface with the REST services at runtime. The artifacts include all the Java classes required to interact with the service. The classes include data type classes, which represent the payload, REST API classes, which represent the modeled JAX RS specified endpoint, and service classes, which are the POJOs, which represent all of the REST API requests. All of these are classes created for you and can be recreated anytime the API definitions change. So let's create the artifacts. Now that we have defined the REST APIs, we can generate the artifacts that serve as the interface between the REST JSON service and the application. So click the Generate Artifact icon. The artifacts are Java 1.8 POJOs. We create a connection and set the Java name to FIF for Fix It Fast. This is used as part of the package naming for the artifacts. Accept the defaults for the generation settings. In the service classes, we select which APIs we want to use for the artifact generation. I'll select all of the APIs for the incidents, get and post incidents, get incident by ID, and get input status. You now see the list of selected APIs. Here you can change the method names to suit your specific needs. Click Finish, and OEPE shows the list of files that are affected by the generating of the artifacts. So click OK to accept the changes. In the Project Explorer, you can see all of the artifacts that were generated. There's a package that defines all of the data types that are required, along with packages that contain the definitions of the REST APIs. The service package contains the REST service Java file, which exposes the request defined in the REST APIs. We now have the artifacts that will serve as the interface between the REST JSON service and the application. Now that the artifacts are created, we need to create the data controls based on the artifacts. Data controls are an abstraction of the REST service interface. This abstraction is what your application will use to provide data to the user interface. To create the data controls based on the REST service, you right-click restservice.java and select Model, Components, Create Data Controls. We accept the default name of REST service, and when the wizard is done, we have data controls for incidents. The core component of incidents is items, which we will be using for our application. As I mentioned earlier, data controls are an abstraction from the underlying data services that provide the data. A developer can use data control definitions to enhance the UI of the pages they build. By default, UI components that use a data control will use the name of the property as the label. you can easily set the label property of the data control to a more reasonable value. I'm setting the value on all the properties to a more formatted and user-friendly value. Once these values are set, any page that uses this data control will use these same labels. So that's all there is to creating data controls based on a REST JSON service. As you can see, the data controls contain methods for each of the APIs we defined. Now let's build a page that uses those data controls. Since we're focusing on consuming REST JSON services, I've already created a MAF feature, content, and an empty page to get us started with the UI quickly. We'll start by adding components to the page. The first thing we need to do is add a layout component. I'm going to add a panel splitter. I'll add it just after the facet before the end of the panel page. I'll accept the defaults for the component. In the panel splitter, there's something called a navigator facet, and that's what we'll use to show a list of items. Now let's look at the data controls that we built in REST service. We see ID, incidents, and status. Inside incidents is an items collection. I'm going to drag the items collection onto the navigator facet and drop it as a list view. There are a number of layout options for list view. I'm using start end and the second variation for that layout. For the start text, I'll use title, and for the end text, I'll use status and set the divider to no divider. Now I'm going to add the details to the panel item. Take the same items collection and drop it on the panel item as a form. I'll remove the image link field and the ID field and click Finish to create the form. Now we're ready to run the application. I'll be running the application in the iOS simulator in debug mode. Click the Debug button and select Debug Configurations. Select MAF Application and click the Create icon. I named the configuration MAF Deploy and select the iOS target. I then select the iOS simulator name. In my case, I'm choosing to use an iPad 2 on iOS 8.3. You could select any of the simulators you want. Click Finish to deploy the application. When the application is deployed, you can see the list of items on the left, which is the navigator facet of the panel splitter, and the right, the form, which is the panel item. As I click different items in the navigator, you see that the form is refreshed with the detailed data from that item. So in this episode, you've seen how you can use a RAML document defined in the Oracle Mobile Cloud Service to create REST APIs in OEPE. You also saw how to generate Java artifacts from those APIs and consume them as data controls in a MAF application. Thanks for watching this Mobile Application Framework video, and make sure to look for other episodes on this same channel.